this is the first question in the question sheet I posted on course website. So let me read it, because as I read, I'm going to take notes. So there's a decision maker, Mr. Stock. Mr. Stock has a wealth, $100 to invest. All right. Sorry. So when I make an assumption like this, it's like he doesn't have anything else. All right. So he has $100 to invest. That's it. Sometimes students are tempted to overthink. Don't. Otherwise, it makes your question and solution, obviously, way too complicated than what we intended. So don't overthink sometimes. So Mr. Stock has a wealth $100 to invest. He can buy shares of an umbrella factory, right? Which for $1 investment, so $1 investment, leads to $10, if the year is rainy. Rainy. And then obviously it may not be rainy, it may be dry. And in that case, it yields $3 only if year is dry, okay? I mean, I don't know. If COVID continues and you have a restaurant, whether you should invest on a restaurant or not, well, if COVID goes away, your $1 investment is going to become $10 a year later. But if it does continue, well, I mean, if you're lucky, obviously, it's going to get $3, kind of, all right? So, the umbrella factory is just a hypothetical example. You can make up your own story. Or alternatively, he can buy shares of an ice cream factory. Okay. And then in the ice cream factory investment, for $1 investment, it pays $2, again, the same amount a year later, if the year is rainy. And then it pays $9 if year is dry. Apparently nobody wants to dry ice cream in a wet environment. The probability that the year is going to be rainy is 0.5. Well, normally we don't really know that. So that's oversimplification, obviously. His von Neumann-Morgenstern utility function is, remember this small u that you attach to each outcome? It's u of x is equal to square root of x, where x is your realized wealth, realized final wealth. Okay? So we have a bunch of questions, like if Mr. Stock invests a fraction lambda of his wealth, remember his wealth is $100, no more, no less, in umbrella, and 1 minus lambda share, when we say share, it means percentage of, right? So therefore, this is kind of a number between 0 and 1. And so 1 minus alpha is again a number between 0 and 1. So 1 minus lambda share in ice cream factory. So question is like, what is expected return of this guy? What is expected utility? And then what lambda maximizes those? So this is, by the way, very simple, very, very simple, the sort of investment decision problem. Okay? So question. What are the alternatives here, or the, actions to choose from? Alternatives. Actions. And what are the outcomes? Okay, so what are the alternatives here? Anybody?
Alternatives are to invest either in umbrella factory or ice
Ice cream, exactly. So there are two alternatives, right? You either choose to invest on umbrella factory or choose to invest on ice cream factory. Very good. Outcomes, however, therefore, so the outcomes, there are like 4 outcomes, right? You invest on umbrella factory and the year becomes dry. You invest on umbrella factory and the year becomes rainy. And symmetrically, the ice cream, you invest on ice cream factory and the weather becomes rainy or dry. Okay? So these are 4 possible alternatives. So therefore, remember your utility function is utility, how much utility, in that case, how much money and how much utility you're going to get out of the money you end up in that alternative, in that outcome. So we have to, you should always have to create a sort of a table which basically summarizes all the alternatives and the outcomes. Right? So here are the outcomes. So each those box are going to give me basically the amount of money in that particular outcome. So on the one side, I'm going to put the alternatives. So here is the first alternative is umbrella. The second alternative is ice cream. Okay. And then here I'm going to put the the state of the world. All right. So the state of the world is rainy and the state of the world is dry. And so again, their combinations, umbrella, investing on umbrella and rainy season, this is my outcome, one outcome, another outcome, etc., etc. So now let's calculate what will be the sort of realized or the final wealth of this guy, if this is the case, So here, however, I don't know if however is the right conjecture here, but it says a fraction lambda of wealth is invested on umbrella and 1 minus lambda is on ice cream. So here, you cannot invest all, of course you can choose alpha as 0 or 1, okay? But here alpha is not yet given. So alpha can be any number in between 0 and 1, but it's a number in between 0 and 1 anyway. So that means you are going to be investing some portion of your money on umbrella, some portion of your money on ice cream. Okay, so that's important. Well, what portion of it? Well, remember you have $100 and lambda fraction of it goes to umbrella. So 100 lambda dollars, remember this is dollar, goes to umbrella. And 1 minus lambda, which means 100 times 1 minus lambda, goes to ice cream. And obviously, as when you add them up, you're going to get exactly 100 because this is the total wealth of this guy. All right? He's just sort of distributing the risk between 2 potential investment opportunities or 2 potential alternatives. Okay. So what else? What we know is that when the weather is rainy, so whenever I talk about umbrella, I mean 100 lambda dollars of investment. Okay, don't forget that. So when the year is rainy, remember, a $1 investment is going to turn to $10 profit. So if I didn't invest $1. He didn't invest $1. He invested 100 times lambda dollar. So therefore, what's going to be his final wealth if the year is rainy? Somebody? Anybody?
Can you say it again? Okay.
So remember, $1 investment on an umbrella factory gives me $10 profit, net profit at the end of the year. But I invested 100 lambda dollars to umbrella, not 1. So at the end of the year, if it is rainy, how much net money I'm going to have?
Going to be 0.25, which is the probability.
Okay, good. There's no probability here. Remember, when we calculate outcome, we don't really care about other potential possibilities. It means the year was rainy. All right, so let's suppose the year was rainy And this guy at the very... So if it is confusing, think of this timeline as follows. This is time 0. Or, I don't know, September 2020. He makes a decision, investment decision. I'm going to invest 100 lambda dollars on umbrella, 100 1 minus lambda dollar on ice cream. So he commits to this. He cannot make any changes. And then a year later, September, same day, 2021, he gets his money back. Obviously, when he makes this decision, he doesn't know whether, this entire year is going to be dry or wet. Right? But what I'm saying is, suppose, remember, I am calculating the wealth for each outcome. Outcome are final deterministic events. So let's suppose the year was rainy. The entire year was rainy. So how much money is he going to have if he invested 100 lambda dollars on umbrella, 101 minus lambda dollars on ice cream?
That's 100 lambda dollars, and umbrella is going to be 100 times 10, 100 lambda times 10.
Okay, very good. Because $1 brings $10, it's going to be 100 lambda times $10. Okay, from the umbrella. Very good. Do I need to write anything else? No, not really, because remember, this is just the umbrella. I am looking at the umbrella investment. Ice cream investment is therefore 100 times 1 minus lambda. Okay. The ice cream factory, remember, if the year is rainy, it brings $2, not 10. So times 2. Okay? What else? If it is dry, however, it's going to be 100 lambda times. Remember, if the season is dry, it's going to bring me $3. And when we talk about the ice cream investment, it's going to bring me $9 if it is dry. Clear?
Would it be incorrect to write the 100 times lambda times 10? Would it be incorrect to write 1,000 lambda?
Well, of course, it's the same thing, right? I just did not write it immediately. I wanted to sort of see, why I'm multiplying with what number. So this is obviously 1,000 lambda. This is obviously 201 minus lambda, right? And this is obviously 300 lambda. And this is obviously 901 minus lambda. Very good. Now what I'm going to do, now I'm going to sort of incorporate the probabilities. Remember, the season could be rainy or dry, but the guy, when he makes his decision, doesn't know this. So what is the probability that the year is going to be rainy? It's 0.5. And the year is dry is 0.5. Okay, so now let's calculate his expected return and expected utility. Okay? So let's open up some space. So expected return first. So expected return has nothing to do with utility, guys. It just tells me basically at the end of the year, a year later, how much money is this guy gonna make in expectation? Well, I mean, simple. In the umbrella investment, he's gonna be making 1,000 lambda, but this is the probability of this event, right? Plus, with ice cream investment, 201 minus lambda, he's going to be making this much money. So I am multiplying it with its own probability. Plus, I keep multiplying $300 lambda. This is basically how much money he's going to make from his umbrella investment if the year is dry. Plus 900 1 minus lambda times 0.5. Okay? By the way, I don't know if it is more confusing for some of you or less confusing, I don't know. I just wanted to show you both ways. You can actually just say, hey, why am I splitting umbrella versus ice cream? Because this guy is splitting his investment with lambda and 1 minus lambda anyway. So I just want to do it at the beginning. I want to write this table as follows. If it is rainy, versus dry. And this is the investment. And so what is the investment? Remember, he's investing 100 lambda, okay? And then he's getting $10 from this, but plus he is making 101 minus lambda dollar investment on an ice cream factory, and in which case he's getting a return of $2. So therefore, this is equal to, this is 1000 lambda plus 201 minus lambda. So 1000 lambda plus 201 minus lambda. So this is if it is rainy. And similarly, if it is dry, 300 lambda plus 901 minus lambda. And then when I want to calculate the expected return, let me write ER, expected return, is just this outcome times its probability, which is 0.5, and the second outcome, the dry outcome with this probability. So therefore, it's 0.5 times 1000 lambda plus 201 minus lambda plus 0.5 times 300 lambda plus 901 minus lambda. Would this be wrong? No, they actually lead exactly the same thing because they are exactly the same thing. All right? So this is how we calculate the expected return. I'm not going to make any simplification, obviously. You can just multiply everything by 0.5, add them up because there are, similar alpha and 1 minus alpha terms. The answer is already posted on the course website, so I'm going to leave it as it is here. But this is how we calculate expected return. Any question? Question? All right. So then, what about expected utility and how is it different? Well, expected utility is how much utility the decision maker is going to get out of his money. And once again, depending on his utility function, this small u, his expected utility and his expected return can be two different things. So, here his if your small u function is u of x is equal to x, your expected return and expected utility will be exactly the same, right? But because the utility function, the von Neumann-Morgenstern utility function is different than u of x is equal to x, the expected utility and expected return will be different things. So what is the expected utility? Well, I can use this table. So remember, this was two probabilities. This is rainy, this is dry scenario, and this is 0.5 probability, and this is the remaining probability. So therefore, the expected utility of this investment is probability times utility of this final wealth. By the way, what is this final wealth? So this is 200 minus 200 lambda plus 1000 lambda. So this is basically 200 plus 800 lambda, okay? Plus 0.5 times this, whatever this is, like 300 lambda plus 900 minus 900 lambda. So this is 900 minus 600 lambda. I just simplified these terms. Be careful. This is u of. So what does that mean? So the utility function is the square root of x. So therefore this is 0.5 square root of 200 plus 800 lambda plus 0.5 square root of 900 minus 600 lambda. Once again, the expected utility and the expected returns are different because there is no square root here. Right? And the square root is simply because of the von Neumann-Morgenstern utility function. Once again, so this is expected utility, that's it. You can't really do more than that because you cannot add those square roots. So you have to leave it this way. The second part of the question is more like an algebra. You know, what lambda maximizes expected utility and expected return? You just take the derivative of these terms with respect to lambda, set them equal to 0 and solve for them. The solutions are there, so I'm not going to do it. What I really care for this kind of problem is how you write expected utility and expected return. That's all I cared. But let me mention one common and very serious mistake. for this type of questions. Some students, when they write the expected utility of this investment, they write it this way: 0.5, 200 plus 800 lambda plus 0.5, 900 minus 600 lambda square root. Okay? Well, this is wrong. This is not expected utility theory. Remember, expected utility was probability times utility of this outcome plus probability of event 2 times utility of getting the second outcome. So therefore, here the square root comes because of the utility function, but this square root, therefore, I'm sorry, those probabilities, therefore, should be outside of this square root, not inside of it. All right? So therefore, this is not an expected utility. It's not von Neumann-Morgenstern expected utility. I don't know what it is. This is expected utility. And so this is a very important sort of mistake. It's not a typo, it's a sort of a serious mistake. And so be careful about it. Yeah,